Hi everyone. Today I will discuss about my journey from web development to game development using open source tooling. For a little bit of a personal background, so you can understand the context from which I'm coming from, I started writing code at a very early age. Discovered Linux at around 14, specifically Red Hat 4.2. Obviously, I'm guilty of a sporadic use of Windows. Went on to using FreeBSD and started my commercial career as a web developer around 2005. I worked as a web developer, technical lead, dev manager, or head of development, using only open source software with a few exceptions for IDEs and other tools. Gradually, however, I have lost my interest in web development and I wanted to transition to something else. The reason I chose web development is because I personally find writing games quite a challenging task. I was also seeking a creative corner where I could basically reignite my passion for programming, in the sense that I was a little bit tired of chasing Jira tickets, and I wanted a place where I could, build things the way I wanted to build. Another reason is that, the game development market is quite large, is actually larger than all of film, television, and music combined. And of course, making and playing games is fun. Uh, my game development experience has been quite limited. I've only done some very basic experiments with programming moving dots on a ZX Spectrum. I played a little bit when I was younger with Visual Basic 6 and DirectX. I've also experimented with Dark Basic, with Babylon JS. And obviously I have no artistic background and no 3D modeling background. Uh, the first project I decided to work on is quite ambitious, I would say, and it's about exploring Mars in real size. For example, the playable area would be made of around 144 million square kilometers, and the game itself will be a little bit like Empyrean Galactic or No Man's Sky. But unlike the two games, and given the complexity of the task, players wouldn't be able to jump from one planet to another, at least in the early stages. The game map is based on NASA scans of the planet Mars, and it would essentially be made of the real geology of that planet. In order to decide which game engine to choose, I had a couple of criteria in mind. One of the criteria was that the game engine itself must run on Linux and must run on Linux without issue and without having to hack the operating system. Also, I had to be able to use any transferable knowledge I had from my previous programming experience. It had to have a strong community such that documentation and advice would be available at all times. And ideally, it should have a visual shader editor, because I had no experience in writing shaders. And obviously, it would have had to be capable of supporting very large worlds. Initially, when assessing which game engines I should choose, I went for Unity 3D and the Unreal game engine. At first, I was exploring Unity, obviously, because it's the most popular game engine. And I also assumed that I would be able to leverage the Unity asset store to be able to build my game faster. Instead, I ended up spending more time finding engine bugs than actually working on the game. And what I found really challenging with Unity is that a lot of the time bugs have been subtle, and being subtle and the engine being closed source, I was never able to actually even confirm whether that was a bug or whether that was something that I was doing wrong or it was a documentation issue. To work around some of these bugs and the limitations in the engine, I also spent a lot of money buying assets, thinking that I would be able to cover any gaps that the engine might have. Also, I have discovered that the high definition render pipeline and the universal render pipelines, although they look good, they are actually quite slow. For example, the HDRP pipeline for a planet, the size of Mars, it would make the game completely unusable. Unreal Engine, on the other hand, which looks good by default, was also slow. The reason for it being slow was obviously because it had a lot of the graphics eye candy enabled by default. And for both of these engines, the Linux versions would constantly break. Like, for example, just the other day, I wanted to take screenshots of my game written in Unity. I wanted to install it on Ubuntu, which is the distribution that I'm using at the moment. And for some reason, it just wouldn't work at all. There were all sorts of errors that I was getting from the installer, and I decided to just give up and not take any screenshots. Furthermore, I found the interfaces in both of these game engines to be quite sluggish, even on powerful gaming PCs. And obviously, especially with Unity, I found the licensing terms to be quite dreadful. It basically made me realize what I have already known about software controlled by large corporations, is that I would end up as a captive customer, and should my game have become successful, I would essentially have been at their mercy. And that's how I ended up testing Godot, which has excellent Linux support. Like, for example, I have used it on a couple of distributions, such as Ubuntu or Kubuntu. I also used it on Manjaro and OpenSUSE without any issues whatsoever, and without having to faff around with the operating system itself. I found it to have a quite a snappy interface, even in the case of my game, where, just to understand, I have around 24,000 height maps, which are basically textures, and even in that case, it basically works without an issue. I also found the engine to be light enough to not get in the way. It's a little bit like in web development, where you can either choose a framework which does everything for you, but the moment you want to step away from the pattern that its creators or the community have found to be useful, then you struggle to build anything new. Godot is also community driven, in the sense that there are plenty of resources and forums where you can find support, and uh, and that means that you would also not be a captive customer, in the sense that you can write your code using, for example, C++ in a way that you could easily transition it to other engines. It's also quite easy to integrate with C++ and other languages, like, for example, Rust, and it's easy to read and understand the source code of the engine. Unlike Unity and Unreal, where you are basically left in the dark and you can only rely on either the community and documentation, with Godot, you can actually open the source code on GitHub, and you can just, browse away to either understand issues or to learn new techniques. Most of my experience of learning Godot has been to rely on the documentation, which is quite good. I found that most of the times concepts in Godot, they are also paired with tutorials. So you can literally learn how to actually build something playable on the spot. As I said previously, I relied a lot on reading the source code of the engine. I was also relying a lot on reading the source code of third-party libraries. And most important, I relied a lot on reading generic game development tutorials. Godot, for example, has a shading language which is similar to GLSL. So anything that you might learn about GLSL would be applicable to Godot. There is also a documentation page which basically translates or helps you translate code from GLSL to Godot's shader language. I was also relying on C++, and oddly enough, I could only find tips and tricks on how to develop a game with a map of this scale in old books and in all the tutorials. Occasionally, I'm also reading Unity or Unreal Engine specific documentation. Like, for example, I'm relying a lot on cat-like coding and obviously on Brake's tutorials. I find that there is a lot of transferable knowledge in that content as well. And finally, I was also reading a lot of research papers to try and understand some more complex techniques. But most of the time, given that I don't have experience in game development, I couldn't actually make much sense of them. But in some small cases, I was actually able to adopt usable advice. Godot also has an interesting piece of functionality. Within its visual shader, you can actually export visually created shaders, so you can explore the implementation of certain features. For example, that's how I learned how to create a parallax shader and a triplanar shader. In terms of programming languages, Godot relies on GDScript. GDScript is somewhat similar to Python, which means that I had a lot of transferable knowledge. And unlike the Unreal Engine and Unity, it means that this being a scripting language, there is no compile wait times you need to wait for when making changes. You know, in Unity, whenever you make a change in a script written in C#, you have to wait for the engine to recompile assemblies. In Godot, on the other hand, the changes are reflected immediately. Obviously, that's not true when you develop in C++, the reason being that you have to recompile the code. But for most of the use cases, you can use GDScript just fine. Also, GDScript has some very easy to use concepts. Like, for example, the first thing that caught my eye was the availability of signals, which made things extremely useful. I wouldn't have had to reinvent the wheel in implementing my own observer design pattern, for example. I could just transmit events from low-level scripts to higher-level scripts using signals. Also, the language itself, even if you don't know Python, I found it to have quite a shallow learning curve. It was pretty much straightforward, and it was extremely useful for writing prototype scripts. For example, in GDScript, defining a function would be done with the keyword func, but in Python, it would be done with the keyboard def. If statements and loops are identical, class constructors, for example, they only have a minor syntax difference. And what you can find in GDScript but not in Python are the signals which I have just mentioned. Previously, I mentioned that you can also code your games in Godot using C++, and that is done using a concept called GD extension. GD extension can also be used to integrate programming languages such as Rust. You can potentially use any other languages in which you can add Godot's bindings. And one main benefit of the GD extension is that you can also leverage existing open source libraries. For example, in my case, I'm using SQLite for inventory management. Again, this is something that I could easily transfer my knowledge from, given that I have been working with databases similar to SQLite. And that means that the inventory management itself, it all of a sudden became not much more than, let's say, like an e-commerce website, where you would have the items of the player, how many of those items the player has, and how they can use them. Using C++ is obviously a lot faster than GDScript. In one case, I found it to be even a couple of 100 times faster. For example, when I'm generating a lot of meshes in parallel, it's happening at lightning speed compared to GDScript. But that doesn't mean that GDScript is not suitable for most of the use cases. Like, for example, if you want to keep track of a player's health bar, or if you want to detect interaction between a small number of objects, then GDScript is perfectly fine. If you have anything involved, like if you want to build an entire planet, then C++ is definitely the way to go. Without going too deep into the technical details of extending the engine using C++, I will just give a brief overview of how it can be done, just so you can understand how, I would call it, trivial this task is. Essentially, all you have to do is to start by cloning your the C++ binding into your repository. After that, you have to export a file which defines the extension API of the Godot version that you are using. You then register the types. The types are basically, the classes that you want to expose to GDScript. Within that class, you bind the methods that you want to make available, and then you go ahead and start compiling your extension. The really nice thing about Godot is that it supports double precision, which means that it can support some really large numbers, meaning that it can support some really large worlds. And achieving that is literally just a matter of passing an extra compile time parameter. Once you have done all that, you can start using your code from GDScript. In terms of IDEs that facilitate the development of your game, I found VS Codium and PyCharm community to be quite useful, particularly VS Codium, which has an extension available for GDScript. It integrates quite nicely with, with the engine's language server. So that means you will get some hints, and you will also get, you will also get any feedback that the language server can provide. However, I found it to be a little bit useless when it comes to debugging Godot code. For that particular task, it's much better to use Godot's native IDE. And obviously, I'm using PyCharm for writing Python utility scripts. Other open source tools and libraries that I rely on, and I should probably mention that before you adopt any open source tooling for your game, you should check your licensing terms and to make sure that it permits redistribution. I found it that, unlike web development, where the source code is hosted and you are essentially providing a service, in game development, the code is distributed. When that happens, the terms of a license agreement, they are completely different. For example, BSD is a little bit more permissive than GPL. Obviously, even if I find that the license is permissive, I still prefer to give attribution and credit for everything that I have used. In terms of tools and in terms of open source tools, I use OpenCV for processing more than 10,000 height maps, which are then converted into smaller height maps, which can be used within the game without overloading the GPU memory too much. I've mentioned that I'm using SQLite for inventory management. I use GIMP and Krita for image editing and Blender for 3D modeling. I also use RenderDoc for Vulkan debugging. And I rely a lot on NVTop and HTOP. NVTop is a very nice tool which is similar to HTOP that will basically display the load of various processes on the GPU. I also find these two tools useful for detecting whether I have memory leaks, which, as it happens, I do have quite a lot of them, but I have been able to fix just by using these two basic tools. I also rely a lot on Sunshine and Moonlight for remote development. Like, for example, if I walk throughout the house or if I go in the garden, I can still connect to my game development machine and I can still edit the game in 4K without any latency. Given that I am using a lot of open source tools, I was able to adopt another concept from web development, which is build pipelines and continuous integration and continuous deployment. The reason I'm double quoting deployment is because unlike a web application, I don't actually do any deployment, but I do continuous builds. Specifically, I'm using make files, again, just like in a web application for orchestrating builds. basically, that's how I'm putting together shell scripts that I use for automated asset processing. And unlike the Unity game engine, which does provide an expensive paid for cloud build solution, I have just built my own dedicated server. I use that server for converting equirectangular images to planar images, which requires, more than 250 gigabytes of RAM. But given that I'm using open source tooling, I'm able to compensate for the lack of physical RAM with swap files. I also use this dedicated server for making platform-specific builds for Linux, Windows, and Mac OS. And ideally, in the future, I will actually add automated deployments, which is that I will try and use the same server for pushing releases to distribution platforms. The code itself sits in GitLab, but large assets are stored on a backup server because we are talking about a couple of 100 gigabytes, and it didn't make sense to dump all of that into GitLab. Obviously, in game development, you also need to rely on quite a little bit of closed source tooling. But being a primarily Linux user, I wanted to identify tools that work on Linux without any hacks. Some of these tools are, for example, Substance Painter and Substance Designer, which, unlike other Adobe tooling, they seem to be working quite well on Linux. I'm also using a terrain editor called GeoGen. I'm using NVIDIA Insight, for example, to debug some parts of the game. And as I previously mentioned, I use PyCharm, and I also use CLion a little bit for C++ programming. But as of recently, I found VS Code to be much more useful than CLion. Then you also have closed source tooling, which is only available for Windows. A couple of examples are World Creator 2 and 3, which are terrain editors much more advanced than the previous tool I mentioned. And there is SketchUp. As I said, I don't really have much experience with 3D modeling, so then when I build my assets, I still need to use a tool as basic as SketchUp. I tried a couple of ways of using these tools into Windows, on Linux. For example, World Creator seems to be working almost fine with Steam's Proton compatibility layer, but SketchUp, on the other hand, doesn't really work on Linux. I've also experimented a lot with QEMU PCI pass-through, but I found that to be a little bit cumbersome, especially because I had to have 2 GPUs, and needless to say, the electricity bill was quite high, but at least I was also heating the house in the process. So then obviously I had to resort to the dreaded dual boot. However, as soon as I find alternatives that work on Linux, I will just switch away from those tools as well. In regards to art, I source most of my art on Quixel Megascans, ArtStation, CG Trader, or sometimes on the Unity Asset Store. If you do source your art on the Unity Asset Store, then you will have to check the terms and conditions of the license, because some vendors might allow using the art in any engine, while others, they might choose a different kind of license. And finally, what I can talk about is also the progress I have made so far. It's taken a couple of years to work on the planetary rendering engine. Personally, I'm not aware of any games that can cover a map of this size with a decent amount of detail. But so far, I have managed to complete the planetary rendering engine. This engine relies on classic mesh generation and skirting, as opposed to cube marching, which was far too expensive for a map this size. I've also implemented artificial gravity, which again, Godot has made much easier than Unreal or Unity, at least based on my own experience. I've implemented the construction mechanics, which rely heavily on raycasts, for example, to detect where to place a construction object. I have to issue a lot of raycasts. I know that Godot at some point has had a lot of criticism around the implementation of this specific piece of functionality. Personally, I have found absolutely no problem. I am currently struggling though with adding more details such as rocks and texture diversity. I will hopefully in the next couple of years, I will find a solution to that as well. And the final item on my list is that I require to implement actual gameplay, to make it enjoyable. This is how the planet looks like at the moment. As you can see, the ground textures, personally, I find them to be decent looking, but there is a lot of lack of detail and the space looks, quite empty. These are this is an example of a construction. This construction is made out of cubes, a little bit like in Minecraft or like in Empyrean Galactic. This is the stuff I mentioned that is using raycasts. Obviously, I need to make them look a little bit better, but I would say that for a prototype, they should be sufficient. Okay, and yeah, this is all of the stuff that I wanted to share, at least at this stage. Hopefully it will resonate with other developers or non-developers that wish to transition from either web development or a different kind of career into gaming. And the message I wanted to convey is that thanks to Godot, you can actually rely almost fully on open source tooling, operating systems, and libraries. And if I have managed to achieve this as someone without any experience in game development, then personally, I think anyone can do it.
Thank